This is Paul Albert, and today I'm going to talk to you about ReCiter. ReCiter is a machine learning-based publication management system. It's built for institutions because institutions have a lot at stake when it comes to publication management. Institutions' competitive advantage compared to other systems out there is that it has a lot of information about the scholars in question, the people whose publications we want to track. As an example, here's all the identity data that we happen to know about one principal investigator here at Weill Cornell. So all this data can be used by a savvy librarian in order to disambiguate Yack and Buck's publications. And that's okay for one or two people, but really what institutions want to do is that they want to track publications for thousands of people. And if you talk to the dean's office and department chairs, they want data that they want lists of publications that are current as of a week, as of the past month, not every quarter, not every year. So ReCiter is optimized to meet that use case. Let's take a look at what one component of ReCiter looks like. This is the publication manager tool. Now what I'm showing you is going to be slightly different than what you see right now on the GitHub repository at ReCiter because the user interface is in flux, so we have some nice new features in the offing. But basically it's going to be very similar. For Yack and Buck, we have a series of publications that come from PubMed. And then, it'll also import complementary data from Scopus. We have plans to include additional integrations, including systems that are less biomedical focused, but for now it's just PubMed. Articles are either suggested, meaning they have no feedback, they're accepted, or they're rejected. And for each article, ReCiter is providing an evidence score. An evidence score represents the confidence that ReCiter has that a particular article was written, 10 being the highest, 1 being the lowest. One of the truths that we should acknowledge about publication management is it's often not the scholar themselves that are providing feedback about it. It's the department administrator or the librarian or someone like that. So that's why this option of showing evidence is so useful. So this is a table that basically matches institutional identity data against article metadata. So what we can see here is that Yack and Buck is our name and our identity system and then an article system, so that seems to be pretty consistent. The grants from our grant system and the article are consistent as well. There's a matching email. The name of the relationships or colleagues is also very useful. So Yack and Buck and line 11 are listed as co-investigators on a grant and they share the same HR unit. So altogether, we can be fairly confident that Yack and Buck wrote this. You can actually scroll through the lot of these and you can say, okay, yep, he wrote all these, except all. And then if you click refresh, what will happen is ReCiter will return back some additional publications based on that feedback. Let me give you another example where the evidence scoring is somewhat advanced. So here's Terry Wheeler. She's my boss. She spells her name with IE, and that's very common for females. So if you look in the identity column here, we use Social Security Administration data to infer there's a 99% probability that someone with this name spelling would be a female. And the article has an author which is spelled Terry, and there's an 81% probability. So that's not doesn't necessarily say that this article absolutely was not written by Terry Wheeler, but it decreases the likelihood, and then it shows up here. You'll note that for every article, ReCiter will identify the putative target author, so that's highlighted in yellow. Identifying the target author is very useful because we'll get a lot of report requests for publications written by a given person in which they were first author or last author. Let's look at another one. So here is Curtis Cole, Dr. Cole. And if you look down here at journal category, we've done an analysis of departments provided in affiliation statements and then look to see how often those departments are associated with a given journal category in science metrics. So one thing that we figured out is that people who say that their department is healthcare policy and research are far more likely to publish in journals where the category is medical informatics. In fact, if you do the odds ratios, it's in the thousands. A thousand times more likely to be in medical informatics than it is to be in some other just random journal category. Here are suggestions for Yi Wang. Yi Wang is one of the most common names in PubMed. 1 in every 300 publications is written by an author with Y Wang as an author name. As you can see, there are only several hundred suggestions. The reason for that is ReCiter will limit the scope of suggested publications in cases where there are a lot of candidate records. So it'll do a search for Y Wang in conjunction with grant identifiers, colleague names, the full verbose name, etc. So we can look at this and we can say, okay, there's a lot of evidence. The relationship evidence in particular is pretty compelling. And then we can say, okay, I'm confident, I'm going to click accept. ReCiter uses Swagger so that developers can get up to speed as soon as possible. So Swagger just lists all the different APIs and then basically provides context and documentation for how to use an API. So I want to do I want to use the feature generator API for Yak and Buck. I input the ID for him, the threshold score. So a score of 5 corresponds to cases where there's a 50% or greater likelihood that a given article was written by Yak and Buck. I should mention now that the scores are computed using machine learning. So we did an analysis which basically took all those different subscores and used support vector machine to identify the optimized weights for each of those. Okay, so there are a bunch of different parameters that you can input here. One that I think is really useful is this retrieval refresh flag. And if you select only newly added publications, it'll only add publications that have been added since the last time the search was run. Okay, so here's what the output looks like. It's all in JSON, which is easy for developers to use. We have a list of all the suggested articles. There's information about the article itself, including the display date here and a standardized date here. The latter can be used for doing sorting. Publication may include several, up to 5 or 6 different publication types, but we use some heuristics to identify a single publication type. It outputs time cited from Scopus. Here's the target author assertion, and then there's evidence about the particular suggestion below. Here's what the architectural diagram looks like. ReCiter can be installed locally or on AWS. You're basically taking data from institutional identity stores. Obviously, the richer a profile you provide, the more accurate your suggestions can be. The data flows through the Java application and is stored in a DynamoDB NoSQL type database. The reason why we use that is that it's optimized for performance, so it allows us to run ReCiter for thousands, 10,000 people every day. The ReCiter communicates to downstream applications through APIs. So here's the publication manager user interface for collecting feedback. Over here, you have a couple of standalone applications. So there's a PubMed application and a Scopus application. And what these do is they interface with those systems APIs, and they insulate developers from complexity. Both of them, when you use their native APIs, they provide data as XML, so we transform it into JSON. With PubMed, we'll do retries if there's a non-response. With Scopus, there's a bug where there are multiple authors, duplicate authors, so we'll exclude those. What else? Okay, so this is the GitHub repository for ReCiter, so it's open source. I should probably mention now that all the data the ReCiter contains and controls, is controlled by institutions themselves. So we've heard from a variety of institutions who say it's very important that vendors not be able to own their data. This is the repo for the PubMed retrieval tool. So people can use this even if they don't want to use the disambiguation service because it's a standalone. There's a Scopus retrieval tool. We intend to release additional connectors, including some that are not focused on biomedical sources. Here's a CloudFormation template repo. So if you do want to install on AWS, you can use these instructions to basically get a full version of ReCiter, including security, all the different roles, all the whole stack up and running on AWS quite easily. You might wonder how much does it cost to run ReCiter. So we run it for 10,000 people every day, bringing in new publications, and our cost is hovering between $300 and $400. Here's a list of all the people who've worked on ReCiter over the years, I should say. And then if there's any follow-up questions you have, or you want to check out the repos, please do so. So thanks a lot.